Okay, so let's start some practice on Mathematica. So the window which you are seeing is the Mathematica's main window. When you open Mathematica, you see this window or the view. So the first thing you can do on this view is that you can enlarge it a little bit, so that because the default magnification is for me is too small, so maybe I can normally put at 150%. So from this window menu, in this way the text you will type, it will be easy to see. Okay, so I will I'm not going to present any training on Mathematica. I will take some problems from our course, and then I will try to solve these problems on Mathematica, and in this way maybe I can introduce you something in the Mathematica. And the thing is that Mathematica is a very comprehensive kind of software. So what I will be basically doing is I will be using it as a sophisticated calculator to solve the problems. Okay, so I have chosen one problem first. So let's see what's that problem is. I will type for you. Okay, dy. Okay, so for typing on the text, you have to see this. There is this plus written over here, so you can type it over here. So I will write an equation dy over dx is equal to y power 2 by 3 minus y. This is the equation. Okay, so this is the equation. So suppose we want to solve this equation using Mathematica. So there are two ways to solve this equation. One is to just use the built-in function, which is the dsolve, and that will directly give you the answer. So let's see this. Okay, function first. So dsolve. Okay, so this function is dsolve. Every Mathematica function starts with the capital letter. Every built-in mathematical function starts with the capital letter, and then we have to write that function exactly the way the function is. So when I started to write dsolve, so then it already has shown me the options, so I can choose this option. So then after this, you will put a right bracket, and then maybe a left bracket, and then you can also put a right bracket as well. And then in between, it will show you a placeholder where I will need to input my parameters which are needed for this function. So in this case, since we are going to solve this above a differential equation, so I have to enter this differential equation here. So differential equation have to be entered into the function form. So what I mean is that in that function form, you will write y as a function of x, and dy over dx as a y prime as a function of x. So since this equation starts from dy over dx, I will write it like y prime, and then bracket x. So this will show, over here, y prime of x is now showing it as a dy over dx. Now I have to put the equal sign. But one thing you should remember, that the equal sign for when you are inputting the equation, you have to put a double equal sign. If you will put a single equal sign, then it will be taken as an assignment statement by the programming by that software, just like it is in many other software. So if you want to represent it as an equation, you have to put a double equal sign. So I will put a double equal sign over here, and then next I will have to put the term y power 2 over 3. Okay, so that is y. So y will be represented as y of x. So now for the power, there are two ways to represent, just like I put on the first statement using the hat symbol by shift 6 key on the keyboard. Another way is to use the more in the subscript way. Okay, so the subscript way is like in this case, I will put the command is control ctrl control and then hash control and then that hat key. Okay, so you will put the control and the number 6 on your keyboard. So it will be it will convert it into the subscript, and in that subscript I can put 2 divided by 3. Okay, so that in that way I will be representing at y power 2 by 3. Then next is minus y, and y will be again represented by y of x. Okay, always you will represent y as a y of x if y is the dependent variable, x is the independent variable. So in this way I have written down the equation. Now I will put a comma, and then I will have to tell what is the independent variable, what is the dependent variable. So in this case, y of x is the dependent variable, and what is the independent variable, x is the independent variable. And that's it. Now I will put enter the shift and enter key to execute this function. So here I have got this value. This is the answer. Here I have got some error. This error is because I forgot to put a double equal sign in the first equation. So that's why when I entered the shift enter, then when the commands are executed, so there was an error. So I can correct it now and then enter shift enter, and then you can see that I have got this equation. But here I have made a mistake in the first equation, although it doesn't make any difference in this desolve answer, because I have put y power 2 and then I did not put a bracket over here. So that's why I think it was important for even in the earlier case for me to use the subscript notation. So in the subscript notation, how I will put the y power 2 over 3, I will press control and then 6 key, okay, number 6 key, and then it will become a subscript, and now it is 2 over 3. And now if I execute it again, so the output of this command will be shown correctly. Okay, so and for desolve, I have already executed it. Yeah, let's execute again. It's the same, and then I have got this as the answer. So in this way, very easily you can solve the differential equation using the desolve command. Here you can see that you are getting some warning, but this warning is okay because it just shows that it is using some inverse function. So in the case of inverse function, some of the solutions may not be found, so it gives some warning. So that is okay. I mean, normally the solutions are correct. Maybe the form or the way we want to see that solution is not the same. Okay, so that was the use of this desolve command. Okay. By the way, in my previously I mentioned a few times as a subscript, whereas I should have said superscript. Okay, so I have not used any subscript up to here. I have used superscript to represent the power. Okay, so please make a note of that. Okay, so now let's continue this question. As I have said that Mathematica I will use over here as a calculator. Okay, although it's easy to use this desolve command and it will directly give us the answer, but we can simulate our hand calculations using the Mathematica as well. So how we can do that? So and simulating the hand calculations by using the Mathematica, and especially at the beginning when we are just starting to learn about Mathematica and differential equations, it will be help us to conceptualize better about the results. Otherwise, this dsolve command is just like a black box, and then we don't really know what actually is this function is doing. So it will be it is then better to represent the hand calculations on Mathematica. So what I'm doing is now I'm doing the same problem by using the manual calculations. Okay. So the difference between the manual calculations and the using the dsolve command is that I will not use dsolve command to find the solution. I will use normal algebraic operations and also the integration function of the Mathematica. So what I have done over here is that I have just pasted this original equation over here, and then I can shift enter. So this is the equation. So now we can see from this equation we can separate the variable. So for separating the variable, I have to divide this equation, both sides of this equation, by this value y power 2 by 3 minus 1. And what I can do is now I can, because I'm using it on Mathematica, I can use the command copy and paste, and then I can enter it. So I will divide it here on the left hand side, and I also divide it here on the right hand side. Okay, so be sure of be careful about the use of parentheses. Okay, and then I can take dx to that side, which means that I can multiply both sides by dx. Okay, dx is here in this equation is nothing just but a variable. It does not have any differential internal meaning as far as the Mathematica is concerned. So Mathematica is taking dx just as a variable over here. Okay. Okay, so I am multiplying both sides of this equation by dx, and then dividing both sides of this equation by y power 2 by 3. And now I'm going to execute this command by shift enter. So I can see that now the variables have been centered. The variables have been separated as shown in this output. So now since the variables have now been separated, now I can integrate both sides. So for the integration, I will again copy this output and paste it here in the next line, and I will use the integrate function for the from the Mathematica. Integrate. Okay, integrate. Okay, so for the integrate, this is the value. So you will this is the function, the full word integrate, and then you will enter the left bracket, and then this function, and then comma, and then here you will have to tell that this function will be integrated with respect to y or x. So this function will be integrated with respect to y. Okay. Now I have to integrate the right hand side, and then I have to integrate it with respect to x. Okay, so in this way, now I will execute the command shift. So it will be minus 3 dy log of this and dx. So here I have got the answer. Here I can see that dy and dx are kind of like extra things, so I can remove it. Okay, in the next step. So just divide left hand side by dy, or right hand side by dx. Okay, yeah, I mean, although it's not mathematically correct, but since we have used this integrate function, so integrate function has took dy as a constant. So we want to get rid of this constant over here from constants over here. Similarly, dx. So in this way, I can get rid of this by dividing